You are looking at a three-phase controlled rectifier. The heart of the device are the 6 SCRs. We have a 208 three-phase supply. We have the load. We have the control mechanism, and we have a set point. We have our SCRs labeled as S1, 3, and 5 across the top, and 4, 6, and 2 across the bottom, which is normal for our natural commutation. And then we have the control lines for each of those SCRs originating from down here. See 1 through 6. The control lines to the SCRs are turned on at the appropriate time, which is why we need the three-phase signal coming into this particular circuit. The set point is here, and that's used to adjust the phase delay for each of the SCRs. What is not shown in this circuit is the monitoring, the protection, the filtering, and to a great extent the control that's necessary to keep this rectifier alive and functioning. At this point we could go on and we could talk about how the individual pieces function together, but I think it's best if we step back and we talk about abstraction and other ways of looking at these devices. For example, in its simplest form, we could say the controlled rectifier is a box. It has AC in, DC out. We have 208 three-phase going in, and we have a variable DC output. This is good, but I think somewhere in between these two levels is a good place for us to live. For example, we could talk about the source being a block. We need a filter. We have our controlled rectifier now, another filter, and the load. Let's not forget the control system, which is used to control the firing angle of the SCRs. A real-life system may or may not have some feedback, as you see here. And that feedback is often compared to some kind of reference, maybe a voltage reference or a time reference. Understand that there are any number of things that we could control for. For example, maybe that load out there is a motor. We could control for the voltage, the current, the velocity, or the position. We may even do all of these at the same time. Now, I mentioned abstraction, and I think this is a really good place for us to look and explore our circuits. At this level, we have enough so that we can explore the general operation. We can see the system level relationships. We can identify the major assemblies. If nothing else, we could think about this as the cabinets. We can come to appreciate the size and weight of the devices, and we can talk about the cooling needs of the individual components. Let's finish this discussion with a maritime application. Here we have genset number 1 and genset number 2. They go through switchgear and are connected up to a common bus. And I'll leave it to you to complete the port and starboard sides here. That switchgear might have an output that goes to a transformer. And here we find a frequency converter, converting AC to AC before it goes to our propulsion motor. We might also have another transformer to run the auxiliary and hotel loads. It turns out that a frequency converter will often have a controlled rectifier in the front end. That rectifier converts AC to DC. That's followed by a DC to AC converter, such that the speed of the propulsion motor can be changed or even reversed. If we were to look inside that frequency converter, we would find a filter. Here's our controlled rectifier, followed by a filter, followed by the inverter, more filtering, and finally we arrive at the load. Our monitoring and control system is much more complex now, and it controls both the rectifier and the inverter. And once again, we have feedback to respond to the load.